let's briefly recall why for fraction multiplication you multiply just straight across, right? So a over b times c over d, y is equal to a times c over b times d. This was a geometric argument that also involved the pizza diagrams. It did a lot, but just as a reminder, starting from a unit square pizza, if you cut horizontally in b equal size pieces and you take the lower a of these b pieces, then you cut vertically in d equal size pieces and you take c of those d, this results in taking a times c pieces of pizza from a pizza that has a total of b times d pieces. So you've got here the fraction multiplication rule comes about by interpreting multiplication as the area of rectangles. And on top of that, how do you really account for the area? You end up talking about and accounting for pieces from a pizza. It just happens to be a square pizza. What does this formula tell us? Just as a reminder, when multiplying fractions, just multiply straight across. Do not cross multiply. So the thing is, this fraction multiplication rule, the thing about, in fact, all of what we're looking at today, it works the same whether your fractions have numbers or variables. Just do the same thing. Be very consistent. Apply the same train of thought. So just like 2/5 times 3/7, you multiply straight across. 2 times 3 over 5 times 7. And yeah, that simplifies to 6 over 35. That's not the big point here right now. This formula works even if the fractions have variables. So for instance, 2 over 5x times 3 over 8x to the second plus 7, just multiply straight across. 2 times 3, well, while that is easy, I just left it as 2 times 3 instead of simplifying it to be a 6. In the denominator, this is why I chose not to even simplify 2 times 3, is because I'm trying not to do any work in the denominator either. So you've got 5x, you've got 8x squared plus 7. I just stuck those next to each other with multiplication sign in between, though I didn't write the symbol. Parentheses are required here around the 8x to the second plus 7. Of course, you could write the denominator differently after if you'd like to simplify by distributing the 5x, but the key point here is distributing would have hid what's really happening here. It would have made it harder to see. So I just thought, let's just multiply straight across and make it very apparent that all that happened was multiplying straight across without any simplifying. Okay, this fraction does further simplify, right? If you do the 2 times 3 is 6 and this distributing that we talked about. But we wrote the denominator the way we did, in part to be lazy, but just because it's easier to spot what's really going on here. Okay, as the next examples are going to show us, it's better to wait on expanding anyway. So you might look at 5x times the quantity 8x squared plus 7 and think, oh, I have to distribute 5x right away. I'd say, well, not necessarily. It's better to wait on any expanding, and by that I mean distributing, foiling, and so on, because before you expand, you have factors. And factors are good. Factors are the kinds of things that can cancel in a fraction. After expanding, you don't have factors. So for instance, right here, take a look. Once you distribute, you have 5x squared plus 35x. And that plus sign, that's the thing that screws us, right? So the denominator does not consist of factors, so you can't do any cancellation because of having distributed. So it's good to postpone distributing till as long as possible until everything else canceled on top and bottom. So let's take a look at this. One fraction times another. So let's simplify x squared minus 6x plus 9 over x squared minus 1 times the second fraction 2x minus 2 over x minus 3. First, it's going to help to factor. So the top of the first fraction, so x minus 3 times x minus 3, or if you prefer to write it this way as I did, x minus 3 quantity squared. The denominator is difference of squares, so x plus 1 times x minus 1. In the second fraction, let's see, you can factor out of 2x minus 2, both terms have a 2, so you can factor out a 2 and have 2 times quantity x minus 1. The denominator, well, that's just x minus 3. Nothing's going to factor there. And just because I felt like it, I threw it in a set of parentheses. Those parentheses aren't required, but since we're about to squish everything together anyway, why not? So here we go. In this next step, this was just a matter of sticking everything together. There is one place where multiplication dot is written, and even that dot wasn't strictly speaking required, right? So here, the work is to not work really extra hard at all. There's no attempt of doing anything, any kind of work, just stick it all together. There is a typo here. This exponent 3 should actually be an exponent 2, so apologies for that. Now you can rearrange the order of some of these things. So like this x minus 3 quantity squared, I just you might choose to do this kind of thing or not, but I put one of the x minus 3 factors here, and there's only one more, and I wrote it back here behind the multiplication dot. What else is in the numerator? There's a 2 and there's an x minus 1. So I wrote the x minus 1 kind of in front and the 2 kind of behind. In the denominator, there's an x minus 3 that I wrote first. The x minus 1 in the middle sort of stays in the same spot. And the x plus 1 that was written first, I've decided to write last. The whole reason of shuffling the order of the multiplication on top and bottom is now take a look. The x minus 3 factor on top and bottom are right on top of each other, right? And the x minus 1 right on top, right below, those are going to cancel. The first x minus 3 written on top and bottom will cancel. The in the middle, the x minus 1 written on top and bottom will cancel, and everything after the multiplication dots will remain. So you have 2 times quantity x minus 3 over x plus 1. And if you want, at this point, because nothing else will cancel, you can distribute the 2 if you'd like to and have 2x minus 6. In the denominator, look, the denominator of fraction is always in a hidden set of parentheses. The entire denominator is. So we could just choose to not write the parentheses, and then we'll just have the hidden set of parentheses around the x plus 1. Okay, so while we could have expanded way back at x minus 3 quantity square, again, this should be a square, sorry for the typo, times 2 times x minus 1, and we could have expanded x plus 1 times x minus 1 times x minus 3, it was better to be lazier, right? Because by not expanding so soon, we would keep having factors, and then we can hopefully see which factors cancel. If you expand it all out, it would just be work to try to factor it all again, just to see what would cancel. So in general, try to think of multiplying x plus 4 and x plus 6 as just writing them next to each other. X plus 4 times x plus 6. To me, this is just squish, just put them right next to each other. That is multiplying. I think a lot of the times students tend to think of x plus 4 times x plus 6, meaning you have to write it like this. To me, this is multiplying and expanding, or multiplying and simplifying. Yeah, but I just want to take the view that multiplying is something much lazier, because sometimes you have to do something lazier in order for it to be possible to notice the cancellation, right? So yeah, here we go. To see when the cancellations might apply in fractions, expanding actually makes it harder. So why do that extra work, right? So just for multiplying, really just stick one thing next to another, because then you'll have factors. Then it'll be easier to spot cancellations. Cancel what you can, and then at the end expand. Okay, remember that dividing a fraction is the same as multiplying by the reciprocal. So here we have one fraction divided by another, and a quick switch around, we can just say multiply and then flip the second fraction, right? Look at the reciprocal. And now for fraction multiplication, we can multiply straight across. We can choose to factor first so that we don't get too visually distracted. In the first fraction, it looks like nothing is going to factor. And in the second fraction, you can factor out an x in the numerator, and the denominator of x squared minus 4 uses the difference of squares formula. So you have x plus 2 times x minus 2. Here we go. We've got one fraction times a second fraction. Just multiply straight across. And again, I really mean multiply straight across, meaning don't work hard. Don't expand anything. Just stick things next to each other. Because expanding would make it so that you lose factors. So that we don't see what factors we have, because we won't have factors anymore, at least the way it would be written if you expanded. At least like this, we still have factors. You see the x plus 2 factor on top and bottom will cancel. You see a 2x minus 3 factor on top and bottom will cancel. You'll be left with an x on top and x minus 2 on bottom. There's no other cancellations possible. So for instance, in x over x minus 2, the x's don't cancel. Because the x in the numerator is a factor, right? You can think of this x in the numerator as x times 1. The problem is this minus sign in the denominator. You have x minus 2, so that x in the denominator is not a factor. It is a term. So there's no cancellations there. We got to know when to stop, and we have to stop at x over x minus 2. Okay, in the work that you see above, I intentionally, in an earlier version of this, I had more parentheses floating around, but what I did, just to emphasize a certain point, is I drew in, I removed all the optional sets of parentheses or hidden parentheses or places where removing parentheses didn't mean that the order of operations changed what it meant. So in the work above, all the parentheses that are drawn in the answer are required due to the order of operations. Okay, this one looks really big, but it's, I promise, not that bad. We've got one fraction divided by another. Let's do the following. Let's first take this the first. Ooh, there are some major typos in that. So apologies for how the first fraction in the answer looks. Okay, but we are going to do a factor by grouping because there are four terms, right? So out of the first two terms, 2x to the fourth and 10x to the third, let's factor out a 2x to the third. You'll have an x plus 5 left in parentheses. If you factor out a negative 3, you'll have a x plus 5 left in parentheses. The denominator is still an x minus 10. Instead of dividing, we're going to multiply by the reciprocal, so that's why there's a multiplication sign in the second line of the answer. And what was the denominator of 3x minus 30 is now written in the numerator. What was the numerator? X squared plus 10x plus 25 is now written in the denominator. Okay, let's continue factoring. So in the first fraction's numerator, let's continue our factoring by grouping. You'll have 2x cubed minus 3, quantity, times x plus 5. And that's it for the first fraction. That's as factored as it'll get. The denominator won't factor. In fact, x minus 10 itself is just in a hidden set of parentheses. For the second fraction, you can factor out a 3 in the numerator out of both terms, and the denominator is x plus 5 times x plus 5, or you could write this as x plus 5 quantity squared. Okay, fraction multiplication. Got to multiply straight across. I just chose to write out the x plus 5 each time separately this time around. We'll see here now that we have factors. See, we did not expand. You can see that one of the x plus 5s on top and bottom each cancel. There will be a leftover x plus 5 in the denominator. And then a factor of x minus 10 on top and on bottom will both cancel. I believe in the end we're going to be left with 3 times the quantity 2x cubed minus 3, and this will be all over x plus 5. If you choose to distribute the 3 that's outside parentheses to the 2 terms inside parentheses, go for it. I think at this point it's a matter of personal taste. I hope that what a question like this one really convinces you of is when you need to multiply, you multiply straight across and don't bother expanding unless you absolutely have to. In fact, it's better to not expand because you'll have factors and you can see what can cancel. Part of the reason for having this specific question was the 4 terms in the numerator of one fraction. And just remember that when you see 4 terms, please think about applying the process of factoring by grouping.